The implementation of a refresh token strategy ensures security, seamless and efficient handling of session-based authentication while minimizing the risk associated with prolonged token validity. Here is an explanation of the best approach for using refresh tokens based on current best practices in application development. Goals of refresh tokens. Extend session lifespan. Access tokens, for example JWTs, have a short lifespan for security reasons. When they expire, refresh tokens allow clients to fetch a new access token without requiring the user to log in again. Improved security reduces the exposure of user credentials by limiting where and how often login credentials are used. Control session management. With refresh tokens, developer can set bounds for when a user session should persist or require re-authentication. Best approach for refresh token handling. Let's begin with generating both access and refresh tokens. Upon user authentication, for example login, the server generates short-lived access token, JWT, with any expiring like 15 minutes, long-lived refresh token, lifespan of a week or more. The access token is sent in the response for immediate use, while the refresh token is usually saved in the client or a secure location. Now let's come to the secure storage of tokens. Access tokens store in memory or use local storage, session storage if necessary. Do not store access token in cookies, especially if they are long-lived, since they often don't need cookies. Refresh tokens for web apps, browser-based, store security in HTTP-only cookies to prevent cross-site scripting attacks. For mobile or desktop application, store inside a secure storage mechanism. For example, keychain on iOS or encrypted shared preferences on Android to protect against breaches. Another thing is to refreshing any expired access token. So implement a refresh endpoint on the backend, allowing the client to send a refresh token to request a new access token. The best practices: use the post method of the refresh token endpoint, send the refresh token in the authorization header or as an HTTP-only cookie. Verify the refresh token on the server. Check if it has expired. Validate against a stored entry in a database. If a refresh token is valid, issue a new access token and optionally a new refresh token if you are implementing rotation. So now we come to the rotation. Implement refresh token rotation, whereby each time a refresh token is used, a new refresh token is generated and returned to the client. The old refresh token is invalidated in the database. If a compromised refresh token is misused, subsequent requests with the old token can be rejected, protecting against unauthorized access. So now let's talk about server validation. Set short expiration for access token from 15 minutes up to 30 minutes. Set a longer lifespan for refresh token from 7 up to 14 days. After this period, the user needs to log in again for a new session. And now let's talk about logging out and revocation. Ensure user can log out entirely, invalidate the refresh token, remove it from the database. If using token rotation, invalidate the most recent refresh token. Avoid storing tokens such as access or refresh tokens indefinitely in persistent storage.